Yeah, it's on. Okay. So hi, welcome back to my math videos. So based on feedback I got from my first videos, I feel um, motivated to do some more. Yeah. Okay. So I will cover things that will all come on the exam, and I will talk about things that will help you solve the exam style questions. Okay. So, if you can zoom in here. So it's all about functions, and this is a big topic that we talked about in quarter one, if you remember, and we talked about many different aspects of functions. Okay, I have a very creative cameraman. That's perfect. Okay, so a function, it's a lot about the notation, how we write it. Usually we just assign the letter F or some other letter, but just one letter as the name of the function. It has an input called x. This is not f multiplied by x. If you think this is f multiplied by x, you will have a problem. You will basically do things wrong and puppies will die. So this is not f multiplied by x. This is f of x. It means that x is the input and f is the rule that you use to calculate what we call the output. So where is the output here? Of course, I didn't write it yet. If I calculate something based on a number I'm giving, the output we're going to call y. So this y here is now my output. Okay, so the easy answer is this is all there is to it. But of course, we can twist and turn with these different concepts, and we can ask many different questions about functions. So as an example, imagine that you are at Spinneys and you're buying food, and you go to the cashier with one apple. So you give the apple to the cashier, and he or she will calculate a number, which is the price of the apple. So your apple is like X is the input, and the cashier will calculate the number, out will pop a number, bing, and you have the price of the apple. So that's your output. And how to calculate the price? Well, the cashier was most likely weighing the apple to see how heavy it is and then calculate the price. Let's say you come with another fruit. Let's say you come with an orange instead, or a pear. Then you take that fruit, you bring it to the cashier, and the cashier is weighing the fruit and gives you another price, another number. So the rule of calculating the price is the same, but based on the input, the output will change. The price will change based on what I'm giving to the cashier. So this is how you can understand a function. It is an input, some sort of calculating, a machine you can say, and then out pops a number. That's your output. And that's how to understand functions. So what can we do with functions? Well, to start off, let's see if we have many different input-output pairs. Pairs of numbers. So here's a coordinate system from -10 to +10 horizontally and the same vertically. Let's say I'm not gonna put exact coordinates. I'm just gonna plot some points here. Let's say I got some input variable. For example, when x is equal to some number here, I applied my function, this f here, I calculated f, and out pops another number, y. Let's say this number is here. So this is my x, and then out pops this number y. Okay, and I can do this a multiple of time. Let's say this was bringing apples to the cashier, and the cashier gives me a price, y. If I instead give me oranges, give the cashier oranges, let's say they're on sale, they're cheaper. So let's say they are here somewhere. I have another x, which gives me another y. So like this, I can do with any single point. And I can draw a line through these points to make it look a little bit like a curve or a graph. And if I have knowledge of how this curve behaves, I can make it smooth. This all depends on the type of graph you are wanting to do. We have done parabola, we have done straight lines, we have done exponential curves. Let's say it looks like this. So usually we write that x is here on the horizontal axis, y is here on the vertical axis. And this will be the function. This curve here is now y equal to f of x. Because for each x that I chose, I calculated it using the rule and out popped the number y. So y, the height of y is equal to f of x. Okay, so one thing I can say straight away is that we have certain relationships that are not functions. And we can see in a graph, if they are not functions, that they are not passing the vertical line test, so-called the vertical line test. Let's do another example. Let's take a circle. Or let's take something, because I don't have a protractor here or some nice engineering type tools to make perfect circles. Let's say this is something that looks like a circle. And let's say I am picking one x value here. I see that I have one y value corresponding to this x here, but there is another y value to the same x that is somewhere down here. So if I'm bringing an apple to the cashier, how is it possible I have two different prices for the same apple? It can't be the case, right? I only have one price for that one apple. So one way, so this is not a function. And the way to see that is if I put a ruler through the graph that is vertical, parallel to the vertical y-axis, and I draw a line straight through it, I see that this line is crossing the graph in two different points. And that's how I know that it's not a function, because it fails the vertical line test. So I can write vertical line test fail. Yeah, because I'm passing two different times. And you see, I can put the ruler in many different places. I can put it here, 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 here. It will always pass in two different places, almost all the time. It's enough that it does it only once and it automatically fails. This guy, however, let's see this guy. So if I take my ruler here and I draw a vertical line straight through it, you see it only passes the curve once. If I draw a line in some other place, here or here or here or here, it will only pass through the curve only once. It means that for every item I bring to the cashier, I will have one and only one price. So if it passes only once, then the vertical line test is passed. Which is very good, because then we know that we have a function. Another question we could ask ourselves is the following. Let's say that I have a parabola. I will do a parabola very quickly, a little bit sloppy maybe, but it looks something like this. You'll see that for any y value, I could pick any one as long as I'm above the x-axis here. You see, I will have two different values on the graph, even though I only have one y value. And if I go down to the x-axis, I see that I have two different x values for that same y value. So I have one x value here, let's call it x1. I have another x value here, let's call it x2. And they both, if I go here, they both give me the same y value. So this is a so-called many-to-one function. So if I draw a horizontal line this time, not a vertical like the other time, if I draw a horizontal line through the graph and the horizontal line passes the curve in two places, here and here, in this case it's here or here, if it passes more places it's also the same consideration. It will be a many-to-one function. Just think about one day you go to Spinneys and the price for apples is the same as the price for pears. So the input is the apple, the cashier weighs it, it gives you a price. If the price for pears is the same, the input is different, it's now a pear, not an apple. But if the price is the same, I'm going to end up in the same point on the y-axis. So that's a way to understand many-to-one functions. An example, by the way, of a one-to-one function would just be a straight line. Oops. If I do a straight line like this, then, and I do a horizontal, if I do a horizontal line test on a straight line, you see it will only pass the graph once. If I do this straight line here, as I did, or here, or here, or further below, it will only cut through the graph in one point. And this is called a one-to-one function. Okay, so all right, we have talked about many different things here. Let's all summarize it on this little piece of paper here. We can say, if this is a function, it means, so vertical line test answers yes or no to the question, is it a function? Yeah, it answers either yes or no. So it's just that I put a vertical line through the graph. And then I had something called the horizontal line test. Horizontal line test. And that only works if I already know that I have a function. The horizontal line test will tell me what sort of function, what type of function I have. Either it's one-to-one or it's many-to-one. So what I wrote in blue here answers the question, what type of function? Something like this. So vertical line test, horizontal line test are the two fundamental things to consider when you have a rule that looks like this. Okay, in the next video we will talk about domain and range, and it's going to be great fun. So see you there. Bye.